I wasn't recording those sounds. Okay. So today we're going to start other types of equations. Cooper, please. We're going to start other types of equations. And you notice on your schedule, we'll continue with other types of equations on Friday. And then we'll do a little bit of inequalities. The main thing is that there's quite a few different types of equations in this section. So your goal is to be able to recognize what kind of equation am I looking at, and then try to have compartmentalize a strategy for each kind of equation. Some of the strategies we can borrow from the equations that you already know how to do, like quadratics and linears. Some of them you have to learn a new strategy to solve them. I have posted, and I also sent you all an email, that the quiz solutions are right on our Moodle site. And I did them with my little cam scanner on my iPhone, and I got it till they got really nice looking, so you can actually read them. They're not blurry. All right. And the other thing is the quiz results for this class are actually pretty good. The median grade for this class was 25 points. We're 25 out of 31. Yeah. So this class did a really pretty good job overall on the quiz. If you didn't do as well as you hoped on the quiz, use that as information for yourself. Something you may be not doing something that would help you. So as I told my first class, come see me at my office. See me in studio. If you can't make my office hours, I'm always here Tuesdays and Thursdays looking for stuff to do, right? That's not true, but I'm really available. So you could say, well, I can't make your office hours because I have a 1 o'clock class. Can you see me Tuesday at 1:30? And I'll say, sure, no problem. All right. And we can talk about all of the things available to you that might help you, help yourself learn more of the material. Typically what happens, and this first quiz tends to point it out, is if you're just going in and doing the homework problems like you did in high school, for some of you who are recently out of high school, and you're just clicking on the little videos when you need them or the examples, and you're doing nothing else, you're not reading the textbook, you're not taking notes on the textbook, most likely that is not going to get you the grade you want. Okay, you really have to read the textbook and look at the examples and also do the homework. I have a few other things up my sleeve I can try to help you with if you didn't do as well on that as you want. What I don't want you to do is to freak out, okay? Because let me just show you something. If you're doing test light, your homework is 20% of your grade, which you have total control over, your homework. There's really no excuse for you to get anything other than a B or an A for your homework, okay? Unless you just don't do it all the time, right? This will be based on 5 quizzes because I dropped the lowest quiz, all right? So we have 6 quizzes, I dropped the lowest, which means each quiz is only 3% of your total grade. So just because it's called a quiz, don't put the amount of emphasis on it and de-emphasize that thing. Now, if you're doing test heavy and you're not doing any homework at all, then this percentage goes up a little, okay? I don't remember what we did, 20% was it for test heavy, or 25? I just don't remember off the top of my head. But it's not a significant portion of your grade, okay? So anyway, we'll leave it there, and I invite you to come and see me if you need to. The other thing I wanted to tell you about is that on class number 3, Jonah pointed out the other day that instead of saying 20% deduction from final score, I pressed the wrong little drop-down menu and it says 20% per day deduction. So if you go beyond 5 days, which you've already passed 5 days for that deadline, and you go in and you do the homework, it will give you a little, you did it right, but it's going to say 0 out of 1 point. Okay, so I can take care of everybody's homework individually. So if you, in other words, if you do it late and you do it right, you can get 0.8 points for each one. So I went in and I changed 4 people in class, their scores. Some of you had 0.6, some of you had 0.4. I changed them all to 0.8 and gave you 18.8 for your total score. Some of you haven't done it at all, so you're going to get a 0 out of 1. That's okay. I'll go in and I'll change your score. Right? So I will take care of everybody's individual homework. Just don't let that bother you. Okay? And thank you, Jonah, for pointing that out. But once the deadline's passed, I can't make like a overall sweeping change for everybody. I got to go in and do it individually. All right, so let's take a look at our first type of equations today, polynomial equations. So what the heck is a polynomial equation? Well, these are kind of the friendly equations because they don't have anything yucky in them. They're basically, we've already done polynomial equations because we've solved linear equations and we've solved quadratic. And polynomial equations are equations that have exponents that are whole numbers. So they have whole number exponents. So that's kind of cool because that's kind of how you think about numbers anyway. You forget about all the numbers in between the whole numbers, like when some of you were doing the set of all positive numbers. You listed 1, 2, 3, 4, 5 like that. There's an infinite number of numbers in between 1 and 2. Okay, so these are the whole numbers. So you'll never see anything like x to the negative 3 in a polynomial equation because that puts the x downstairs in the denominator. So that's called a rational equation. So polynomial equations will always be kind of friendly looking to you. There's no fractions for your exponents. We'll get to that at the end of class. Ooh, good. There's no radicals in here. Really nice numbers for your exponents. Okay, so here's our given equation. Does anybody, we call this a 4th degree equation because the highest power you see here is the 4th power. And also what it tells you is that you could expect possibly 4 different solutions. That's your maximum. This represents the maximum number of different solutions you can see. Now, you may not get 4 different. You might get 3 different or 2 different. Okay? You'd get 1 different if this was x to the 4th equals 0. You'd only have 1 solution. But this tells you how many types of solutions you could expect when you solve this equation. So before you even begin your work, you can start imagining what you should be looking for answers. Okay, so we're going to borrow the idea that we use from quadratic equations. Quadratic equation says scoot everything over to one side and have 0 be on the other, and then try to turn one of your sides into a pure multiplication problem and use this idea called zero product. If you have it all written as multiplication, then all you have to say is what makes each individual factor equal to 0. So if we want to do that to this equation, what would we subtract from both sides? 6x squared. Now you could divide x to the 4th. You could subtract x to the 4th and x to the 3rd. But why do more work when you don't have to, right? So we're going to subtract 6x squared from both sides. And when we do that, let's see what we get. We get x to the 4th plus x cubed minus 6x squared equals 0. Okay? So that's your new equation. It's the same as the original equation. It's just been rewritten as an equivalent. Now, I'm going to harp on this over and over again, and you'll see me do it on your quizzes and your tests. You solve an equation by writing an equivalent equation. So as you go from one step to the other, this is one of those picky math teacher things, as you go from one step to the other, you should always see an equation. Now, you're not going to do it here, but I'll show you where you tend to just drop off that 0. Okay? Always solve an equation by writing an equivalent equation. All right. Now, I have this little thing in this phrase here in big capital letters, never divide both sides by x squared, which is a tendency when you look at something like this. You say, oh, why don't I divide both sides by x squared so it will look like this? Look. If you take x to the 4th, I might as well do it on the overhead so you can see it. So a lot of sort of intuitive, like to make the problem easier, you go like this. You say, oh, I'm just going to divide everything on both sides by x squared. That will turn this into the kind of problem I know how to solve, it will turn it into a quadratic. And then I can solve the quadratic. What's wrong with that? That looks legitimate. Who's talking? Oh, Dan? Right, we're gonna miss a solution. In fact, x squared has potential of two solutions. Well, it's the same number, 0. So you're missing potential solution when you do that because you're turning a 4th degree equation into a 2nd degree. And in this particular case, if x is 0, which it is, that's one of your solutions, you're dividing both sides by 0, which you can't do. So avoid that temptation as step 1. Okay, you don't want to divide by any variable x squared, x cubed, whatever it is. All right, so in order to use this kind of idea we use for quadratics, we need to factor the left-hand side of this equation completely. And which factoring technique are we going to use to do that? What's on your palms? Look on your palms. What's on your palms? What's on your palms, Seth? What tattoo? What is it? Greatest common friend, right? Your greatest common factor. In this case, the greatest common factor, we got to find a name for C. Greatest what? Chumby friend, greatest, something other, all right, greatest common friend, forget it, Linda, is x squared. So we're going to factor this by pulling out x squared as a common factor. And notice what we have left inside the parentheses is a quadratic expression, which you've learned how to factor over and over again. So right now, you look at this and you say, I know what's going to make x squared equal to 0 when x itself is 0. I'm not quite sure what makes this equal to 0 yet because it's an addition and subtraction problem. I want to make that into multiplication as well. So you've got one more step. You keep your x squared out front. Don't let that go away. And you factor this. Factors of 6 that differ by 1 are 3 and 2. I know the 3 has to carry the addition sign because I ended up with an addition sign in the middle, and voila, I am done. Now notice you really have 4 factors here because if you take x and you write it like this, you see you have 4 factors. 3 different factors, x plus 3, x minus 2, and x. So that shows you that 4 in your original exponent. You could see 4 factors there. Only 3 of them are different. So you're really going to end up with 3 different solutions. Okay, 3 different. Because when you set x squared equal to 0, that's the only time you have this is a quadratic equation, x squared equals 0. It's the only time you have a single answer for a quadratic because plus and minus 0 is the same number, x equals 0. So there's one solution. Then you set x plus 3 equal to 0, and we get what? X equals -3 as a solution. And then we have x minus 2 equals 0, and we get x equals 2 as a solution. So notice we have 3 different solutions, but later on when we study graphs of polynomials, we're going to say there's 4 zeros. I'll tell you about that in a minute. Always check your answers in the original equation. So we'll do one. The original equation looked like this. X to the 4th plus x to the 3rd equals 6x squared. Well, the easiest one to check is 0. That you can look at and tell 0 equals 0. Let's check out this -3. -3 to the 4th plus -3 to the 3rd equals 6 times -3 squared. Now notice, whenever your value of x is negative and you're using powers that are even, you always got to put them in parentheses. Always got to put those negative numbers. So we've got -3 to the 4th. Does anybody know that off the top of your head without your calculator? 81, okay. Minus 27 equals 6 times 9. 81 minus 27 is 54. 54 equals 54, you're a happy camper. Okay, it checks. And then you do a similar thing for your other solution, which was 2. Okay. So your goal here is to try to turn whatever type of equation you're looking at into a simpler equation, like a linear or a quadratic. So notice we turn this fourth degree equation into a quadratic equation here, x squared equals 0, and then two linear factors, because the highest power you see here on these is 1. You don't see it because it's not there. We don't write it. But both of these are now linear equations. So we're able to take something that was fairly complicated and sort of simplify it down to the point where we could handle it. That's the goal when you have polynomial equations. Most likely, if you think about it, they're not going to give you a linear equation, and they're not going to give you a quadratic. They're going to give you something higher, x cubed, x to the fourth, x to the fifth. So your greatest common friend, your factor, greatest common factor will be key to solving any of these equations, okay? So that's really the key step for remembering how to do these. All right, so what else are they going to throw at you in this section? Well, I'm going to skip the calculator stuff for now. I want to just get to a couple of equations, and then we're going to do work on our own, and then I'll come back and do the calculator stuff. So let's take a look at the other type of equation, radical equations. Okay, these aren't too hard to recognize, radical equations. So if you turn your page to step 4, okay, radical equations, it's like banging you over the head. I'm a radical, see me, here I am. All right, so it doesn't take much to recognize them, but we want to figure out how do we solve them. And we use the age-old strategy of isolating our x term. But then the question is, wait a minute, we've got x as our first term in this equation and square root of x as our second term. So which one do I isolate? Okay, square root of x. Why? Okay. All right. So what do you, so let me see. I'm going to go over here. Chris is saying isolate the square root. So to do that, you would subtract x from both sides. And Septov, what are you saying to do? X squared. X plus x squared. How do I make this into x squared? So square this one. But if I square this one, don't I have to square all of it? Yeah. For an equation, you've got to do everything, both things to the same side. So you don't have a right to just go in and change that one because you don't like the way it looks, okay? So remember, if you're working with an equation, whatever you do to one side, you've got to do to the other. All right. Now, there's no rule saying that you have to isolate the radical here. You could isolate x. I wouldn't recommend it because it's going to be a lot harder to solve. It's not going to get you to your end goal, because if you try to do this, the only way, remember, we don't know how to solve an equation with a radical in there. We've got to get rid of the radical. The only way to get rid of the radical is to apply the inverse operation. That's what solving equations really do. When you subtract something from both sides or divide both sides by a quantity, you're doing the inverse operation. So to undo the square root, what's the inverse of a square root? How do you undo it? How do you get back? You square it, right? So you can see in the case that Chris suggested, if you squared this side, you must square 12 minus x. So guess what, folks? You better put 12 minus x in parentheses before you square it. All right? If you do that, you see you're going to get x here, and then you'll multiply that out, and you'll get 144 minus 24x plus x squared. We'll get there. If you decided to isolate this, the x, look how ugly it is on the right side. You square that baby, and then you square this. Ooh, I don't know about you. Then you've got to do this, 12 minus the square root of x times 12 minus the square root of x. And guess what? You're still going to have a radical in there. So even though you could get there eventually, it's really messy and ugly. So the moral of the story is when you have a radical equation, you want to isolate the radical term. Radical term. In this case, your radical term is square root of x. And you subtract anything that's being attached to it, or divide by, if they had a number in front, a coefficient, you would divide by the coefficient on both sides. In this case, you want to subtract x from both sides. So we're going to do that. We're going to subtract x from both sides, and we get the square root of x on our left side and 12 minus x on our right side. Then put that in parentheses. Make sure you see that as a single quantity. All right. Now to undo the square root, we do this by performing its inverse operation, which is to square both sides of the equation. So now I'm going to take my equation and I'm going to square both sides, because whatever I do to one side, I have to do to the other. And now the square and the square root undo each other. That becomes 1. And the reason is all of those exponent properties you reviewed and saw and have all set in your mind for today. Square root of x is written like this. And when you square it, when you have a power to a power, you multiply your powers. Guess what? 1/2 and 2 are reciprocals of each other. So that gives you x, because you get 2 over 2. So that's why they undo each other. And now you have to square the binomial. And hopefully you did not get this wrong on your quiz. When you square a binomial, to be safe, unless you know the formula from doing it over and over, just do it out the long way with FOIL. You get 144 minus 24x plus x squared. Okay, so that's the temptation part. It's not 144 plus x squared. Okay, it gives you 3 terms, always 3 terms on your right side there when you square a binomial. Now, what kind of equation do you have looking at you? Quadratic, because the highest power you see is 2. So to solve a quadratic, you set one of your sides equal to 0. So let's subtract x from both sides. And we get 0 equals, and I'm going to rearrange this with the highest power first. I'm going to put my x squared first, minus 25x plus 144. Okay, now you have to solve this quadratic, and that's why we spent the whole class on, was it just Monday we did this quadratics? Yeah. So you solve that quadratic equation, you have a couple of choices. You can either use the quadratic formula, or you can factor it. And it doesn't take too long to factor it. If you just, on the side of your paper, do some factors. 3 doesn't go into it because, yeah, it does, because 4 plus 4 plus 1 is 9. So 3 goes into it. 3 goes into it 48 times. And then you start looking for factors of 48, 6, 19. And guess what? 6 and 19 add up to 25. So those are the 2 numbers to factor. So x minus 19 times x minus 6. Voila, you got your answers just like that. Boom. Or you could do a equals 1, b equals negative 25, and c equals 144, and go through the whole quadratic formula routine. Okay, whatever you want. However, here's the key. And this isn't just your math teacher, oh, check your answer because it's a good thing to do. Anytime you square or you raise a radical equation to a power, you can introduce false solutions, because you've turned an equation that was originally the highest power you saw right here was 1 into quadratic. So you have to, it's mandatory to check your solutions. Cooper? 19 times 6 doesn't equal? Oh, so what did I do? I screwed up? Okay. So what is it? 19 times what? Oh, so 114. So, oh, I screwed up. All right. Well, maybe, let's see. let's see, is 6 times 24? Well, that doesn't help. No, 12 and 12 add up to 24, not 25 in the middle. I must have screwed up here. All right. So I screwed up. How about 8 times 17? Does that work? Oh, it's 16 times 9. Oh, okay. Oh, I knew it was in there somewhere. Okay. 16 and 9. There we go. 16 and 9 add up to 25, and 16 times 9 equals 144. All right. So I made a mistake. I was trying to go too fast. This is typical, right? We all can go a little faster sometimes and make mistakes. So 16 and 9, if you do your quadratic, you're going to get, you'll wind up with this, 25 plus or minus the square root of 49 all over 2. If you use your quadratic, the minute you see this, folks, the minute you see a perfect square under there, that tells you your original quadratic is factorable. Anytime you get a rational number for an answer, you can always factor. So if you got that far with your quadratic, you say, okay, x is 25 plus or minus 7 over 2. So it's 25, so x equals 25 plus 7 over 2, or x equals 25 minus 7 over 2. 32 divided by 2 is your 16. 18 divided by 2 is your 9. Okay? Thank you, Cooper, for that. Okay. Okay, so let's get back to this remembering you have to check. So I'm not going to circle these right now. I've got to go back to my original equation. So let's go back and check the 16 in my original equation. So x plus the square root of x equals 12. So x equals 16. 16 plus the square root of 16 equals 12. 16 plus 4 does not equal 12. That's what we call an extraneous solution. You just cross it out. You don't even have to know the fancy name for it. All right. Let's check our 9. Hopefully we did all this work and we got one answer that's correct. 9 plus the square root of 9 equals 12. 9 plus 3 equals 12. Yes. Okay, I found the right solution. All right. So the moral of the story, folks, every time you solve a radical equation, check your answers, because you know on my math lab, they're going to have the little solution set hanging out down there. And if you try to put 9, 16 in there, they're going to go, right? The only answer, the only solution here is 9. All right. We have one more equation to solve, one more type, and then I'm going to set you loose for about 20, 25 minutes, and then we'll come back to the graphing calculator. To do these, you have to remember how to do this kind of thing. Okay. And I asked you to review sections P2 and P3 by class 8. Guess what class this is? 8. Right. Huh? I heard something, I didn't hear it. All right, so how do we do these? You just don't, okay? You'll be in trouble.
I can see it, but I can't say it.
You want to come do it? 3 root 16. So root 16 looks like this. Root 16, doesn't that go through Conway? No, go ahead. Yeah, root 6, and then what? 3 in front like that, like a radical, like a coefficient?
Thank you. The third root.
Oh, I thought it was a square root. You tell me it was.
I know, but I did that.
Well, what root is it? Oh, we better know what root it is. Oh, this always show offs, huh? Square root, I'm only teasing. Square root raised to the third power. First, cover up that denominator. Doesn't 3 act like it always acts? It's a cube, right? So somewhere along the way, you got to cube it. This is what's bugging you. When you have a denominator as your exponent, that's telling you what root to take. Now, if any of you grew up in this area or have any family friends that are farmers, where do they put their roots after they harvest the roots, whether they're potatoes or carrots? Where do they store them? The compost? No, I wouldn't store it in the compost if they're good, I don't want to throw them away. But you could put it in the compost or give it to your chickens or your pigs, yeah. But if you want to store them to eat them, where do they go? The root cellar, right? Roots go in the cellar, in the denominator, okay? So you take the square root of 16, and then you cube it. So it's 64. That's the answer to that. What about the next one? What root are you taking? Cube root, because that's the denominator. Cube root of 8. And then what do you do to it? Then square it. All right? So it's 2 squared, which is 4. All right? Now, the part that you always forget about, you don't think about this, but it's really cool. Let me show you another way to do that. Write 8 like this. 3 times 2/3. 16 to the, what was the other one? 3/2. You can write like this. There's so many different ways to do exponent problems. That's kind of the problem with learning it, is like, which way do I do? Well, do whatever way works for you, okay? This is kind of like when you're a little more practiced and experienced, you kind of feel more comfortable doing this. Okay, so let's take a look at a problem, an equation that has a fractional exponent. So when you see something like this, you say, this is not a polynomial equation because I don't have a whole number for an exponent. Okay, so all of these things can be written as radicals. So you could turn this into a radical equation. It's really up to you. It can get a little messy. I'll show you both ways how to do it, but I would prefer right now to show you how you solve this type of an equation, which we call an equation with rational exponents, using another method. All right? So where do I begin? To tell a story. Da, da, da. I know I can't think of any new songs. This is really old, before most of you were born. Love stories. Anybody ever heard that song? No? All right. Anyway, so where would I begin here? Well, you begin where you always begin. You isolate. Think of this simply as 3x minus 6 is 0. Don't get all freaked out by that little itty bitty fraction. What would you do? You'd add 6 to both sides as your first step. So let's do it. Let's add 6 to both sides. Okay, you're done. Almost. Right? Now, if that was 3x equals 6, what would your second step be? Divide both sides by 3. Right. So let's do that. And I get x to the 3/4 equals 2. Now, here's where the new idea comes in. We don't want x to the 3/4 equals 2. We want x to the 1. We just want x equals some number. So you have to, yeah, you multiply, or you raise both sides of the equation to the reciprocal of this power. Why? Because when you have a power to a power, you multiply your powers. So you want to make a 1. So what number do you multiply 3/4 by to get the number 1? It's reciprocal, 4/3. So you raise both sides of the equation to the 4/3 power, and you're done, because this is x to the 12 over 12 equals 2 to the 4/3. X to the 12 over 12 equals x to the first, and there's your answer. 2 to the 4/3 power. You can't simplify it because you can't simplify the cube root of 2. It's an irrational number. So that's your answer, 2 to the 4/3. Okay. Or you could say 16, the cube root of 16. Either one. You could do this if you want. Cubed root of 16. They both say the same thing. But it's irrational. Please do not put this in your calculator and give me a decimal with an equal sign, like many of you did on that second problem on the test. I want the answer. This is the answer. If I ask you for an estimate rounded to the 100th, 1,000, then put it in your calculator. Sometimes the calculator is your worst friend, okay? if I don't ask for an estimate, give me the exact, always. All right? So that's the exact answer. You can check it by throwing it back into the equation. Why don't you put this back in the original equation and see if you can check to make the left side equal the right side. Okay, you'll have to use an exponent property to do that. So give it a shot and I'll help you out if you need it. All right, so alternatively, you could turn this into a radical equation if you wanted to by doing this. Some students actually prefer this approach. You turn it into a radical, and then you say, okay, to undo that radical, I have to raise both sides to the 4th power, and that disappear, it becomes 1, and you get x cubed equals 2 to the 4th. And to undo x cubed, you take the cubed root of both sides. And there's the same exact answer you got a minute ago. The cubed root of 2 to the 4th. We just wrote it this way, which they're both exactly the same. So some students will turn it into a radical equation and do it. It's really up to you, however, whatever way you prefer. So now I'd like you to take 20 to 25 minutes to work on those 4 problems that are on your activity, and then we'll come back to looking at how your graphing calculator can solve some of these problems for you. Number 2. So sometimes we get these polynomial equations. And, oops, I don't have my earphone. Sometimes we get these polynomial equations. Okay, we got to turn Frank off. Okay, we get these polynomial equations, and if we try to solve them algebraically, they're either impossible to do algebraically or very difficult. So this is where, and you'll get a question like this on your test. So I want to show you this. Jonah, can we move to this section now so that you have this section up? Just want to make sure you have this for your test. Okay, so if you have a polynomial and I ask you to solve the polynomial algebraically or graphically, this is the section you want to refer to as number 2 and 3 in your notes. There's 2 approaches. They use different ideas. Some of you may relate more to one idea than the other, and that's okay, but I want to show you both approaches. One approach is to set the polynomial equation equal to 0, just like if we were going to solve it algebraically. So we're going to turn this equation into the following equation. Okay. And then we're going to enter this equation into y1. Okay, we're going to set this into y1 on our graphing calculators. All right, so let's clear everything out. I have to clear everything out. So we have what? X to the third plus x squared minus 4x minus 4. All right. Now, first of all, I want you to notice the difference between the equation we're trying to solve, which is this equation, and the equation that's in your calculator. The equation in our calculator is an equation with 2 variables, which means we have an infinite number of solutions. We can pick an x, cube it, square it, subtract 4 times that number, subtract 4, we get a y value. That's a point on a graph. So this will have a picture with an infinite number of x, y points. Okay, it's going to be what we call a cubic. This equation is solved for one value of y when y is 0. So you're trying to find the x values that make y 0. Where do those appear on your graph? The points that have y equal to 0. What do they look like on a graph? The x-intercepts, right. So what you're doing is you're going to graph the entire equation and then look for the spots where y is equal to 0, because that's what you're interested in. Where is y equal to 0. That's the concept. That's the idea. So let's graph this. Do zoom 6. Zoom 6. There's your graph. I'm going to take a picture of it. Here we go. You draw a picture of it right in your own paper. Since you can't cheat as easily as I can, you just do a replica of what your graph, what you see in your graph right there. Okay, there it is. Beautiful graph. Okay, so we're now interested in finding the values of x that make y 0, because that's the equation we're trying to solve. The values of x that make y 0. And notice they're sitting right here. Those are the three places, the three values of x that make y 0. So how do you find those three spots? And this is what you would do on a test. When I say, show me all of your steps, you would say, I enter y1 equals that equation we just did. So this is the type of thing I would expect to see. I hit, I find the graph, and then you're going to copy the graph on your paper. And now you show me that you know how to find the answers. You say, I go to second trace, which is calc. You can say, I go to the calc menu. And now you go to 0, because you're going to find the values of x that make y 0. So you go down to number 2, you hit enter. All right. Now, this is the part that's, I can show you a really easy way to do it. When you're trying to find the value for one of those x-intercepts, let's say we want to get the value of this x-intercept. Pick any number to its left. Want to give me a number to the left? -7. So I enter -7. So I enter -7. And then I pick a number to its right. Now, this is the only time you got to be really careful. Notice a number to the right of this. If you go too far, you're going to go right by one of your other solutions. So you've got to pick a number in between those two x-intercepts. So just pick anything, -1 point anything. I'm just going to pick -1.5, 1.5. So then I enter -1.5 for my left bound. So this was my, excuse me. Uh-oh, hang on. Excuse me. I got to delete. I hadn't hit my enter yet. Delete, delete, delete. That's my left bound. Now I'm going to hit enter. And now I'm going to enter my right bound. I'm going to say -1.5. Hit enter. And then where it says guess, I hit enter again. And let's see what I got. -2, 0, right? So the answer is -2, 0, because that's the point on the graph that gives you y equals 0. But what's the solution for this equation? What would I write as the solution? What value of x makes y equal to 0 here? X equals, so that's one of your solutions, right? And then you just take a picture of that, or you don't actually have to. I'm going to take a picture to show you on your notes what your calculator says. And you got an error when you did it, Gina? Okay, good. All right, so let's suppose I want you to find one more value, go through the steps and find, we know what the answers are, -1 and 2, but see if you can do these steps on your own and find one more x value. The three answers are going to be -1, -2, and 2. See if you can find one more 0. We call these things zeros of this equation. And then I'll show you the second method. Yep, Chris? Short week, I guess we should call it. All right, so the other idea that we're going to borrow from class 5, where we drew two different graphs and saw where they intersect, is to treat this equation, the left side as y1 and the right side as y2. So we started off with this equation, x cubed plus x squared equals 4x plus 4. So don't put everything on one side. Just treat the left side as y1. So let's throw that into y1 on our calculators. It's a little different idea, but it gets us to the same result. So we put in x cubed x cubed plus x squared. And then we put the second part of the equation, the right-hand side, as y2. So we say 4x plus 4. So let's hit zoom standard and graph to locate the x value of the intersection. So now we're going to get two different graphs, and we're finding the common solution, the two places where they intersect. So we'll hit zoom standard. So our first one is a cubic, and our second one is a straight line. But notice I can't see it all. So I've got to go higher than my y max is 10. So I go back to my window, and my y max is got to be, I'm just going to say 20. And you know what? I don't really need all those x minus 10 minus 9. So I'm going to actually just shorten up my window a little bit, which will help me to zoom in. I'm going to go there, and I'm going to just bring this window a little closer. And let's see what my graph looks like now. So I've just changed my window. I can see things a little better. I can now actually see the 3 spots where I intersect, right? So this is now what my graph looks like. And you already know that you have 3 answers from doing this equation the other way. So here are the 3 points where they intersect. Right there, and right there. Okay. So how do we find those intersection points? Well, we go second calc and we look for the word intersect, and there it is. It's number 5. So this is where you've got to bring, you do have to bring your cursor close to the intersection point. I'm going to come down because my first intersection point is down there. And now once you get it close to the intersection, you just go enter, enter, enter. Voila, there's your answer. Notice it's -2, -4. It's not 0 anymore because it's a common point on both curves. If you put -2 in here on either side, you're going to get -4 equals -4. So it's a different idea. So the x point, the x value that gives you that common y value on both of these graphs is -2. Then just move your cursor along. Okay, go back to second calc. Go down. You have to do this 3 times. Okay, enter. Then move the cursor along. It's close to your second point of intersection. Then enter, enter, enter. It's really cool. And you get your second x value. And then you hit second calc, intersect again. Move your cursor along so that you're somewhere close to that third intersection point. Hit enter, enter, enter. And x equals 2. And voila, there are your 3 solutions. Have a good rest of your week. We probably won't have classes tomorrow. We will hopefully have class on Friday. I will email you, and come on up and get